By Pythagoras theorem, we can say that yes, AC squared is equal to AB squared plus BC squared. Let's still take this to be C, the hypotenuse to be C, the opposite to be A, and then the adjacent is B. So C squared is equal to A squared plus B squared. Let's find, I want you to help me find sine of theta. If we want to determine sine theta, how will it, what will that be? Sine theta. Can anybody help? Sine, Frank.
Opposite of hypotenuse.
So I have represented the size with letters. So give me
It's going to be B over
opposite. Opposite. The opposite is A. So A over
B.
over C. Please, sine is opposite over hypotenuse. So opposite over hypotenuse. Okay. So we represent this in a form of acronym. So, all right. So it means that if we square sine theta squared, which we also call as sine squared theta, this is equal to A squared over C squared, right? Help me determine cos theta. Cos theta. Yes, can anybody help? Cos theta.
B over
B over what?
B over
B
A.
over
So B over C. Cos is adjacent over hypotenuse. So this is K. So C represents cos and A adjacent over hypotenuse. So cos theta is B over C, meaning that cos theta squared, which we also refer to as cos squared theta, is B squared over C squared. Giovanni.
C square can't use square theta.
No, it is the whole of cos squared. The whole of, we are squaring everything cos theta. So we put that into bracket and then square it. Okay. But this is also termed as cos squared theta. Another representation of the same thing. Okay. Now, if let's add sine squared theta and cos squared theta. When we add this, we have A squared over C squared plus B squared over C squared. Let's simplify. If you take the LCM of the denominator, which will be C squared, this goes into this one. One time this, we have A squared plus This is also b squared. So we have sine squared theta plus cos squared theta, giving us a squared plus b squared all over c squared. Class, look at the numerator. What does the numerator represent? What does the numerator represent? Can somebody help?
Hypotenuse.
That's the hypotenuse. So a squared from Pythagoras theorem, a squared plus b squared is equal to the square of the hypotenuse. So we can say that this is c squared over c squared. And class, what is c squared over c squared?
1.
1. So this is the proof of the fact that if you have any angle, when you take the sine of the angle and you square it, you take the cos of the angle and you square it, the results must be equal to 1. This is the proof. Are you okay, class?
Yes, please.
All right. So put the triangle law of vector addition down for me. The triangle law of vector addition. And let me bring that to memory. If you have the triangle law of vector is represented like if you have two triangles, whether they are two vector quantities, whether they are perpendicular or at an angle. To find the resultant, we realign the direction by using equal vectors. Equal vectors are equal in magnitude, same direction, and they must be parallel. So, looking at the directions, we can say that the resultant, which is the short, it's as if this vector is moving from here and then following up with the other one. So if we want to come here, the shortest possible distance must be moving from here to this point, or drawing a vector from the tail of this one to the head of this one, and this becomes the resultant. So the resultant obeys the triangle law of vector addition, that if this is A, this is B, then this is also B, this is also A. Let's represent the resultant by C. Then we can say that the direction of vector C must be equal to A plus the vector B. This is the triangle law of vector addition. Triangle law of vector addition. Mathematical representation of it. Let me give you word representation because it can be asked that states the triangle law of vector addition. I'm reading. Are you ready? Hello, class. Are you ready?
Yes.
Right.
Yes, sir.
Okay. So the triangle law of vector addition states that the triangle law of vector addition states that when two vectors are represented as two sides of the triangle, when two vectors are represented as two sides of the triangle, with the order of magnitude and direction, with the order of magnitude and direction, then the third side of the triangle, then the third side of the hello?
Sir, please, can you go over?
No problem. You let's finish. I'll go repeat it twice for you. Then the third side of the triangle represents the magnitude and direction of the resultant vector. Then,
Sir, please, the third side of the triangle.
then the third side of the triangle represents the magnitude and direction of the resultant vector. I'll go over. So the triangle law of vector addition states that when two vectors are represented as two sides of the triangle, are represented as the two sides of the triangle with the order ORDER, with the order of magnitude and direction, with the order of magnitude and direction, then the third side of the triangle represents the magnitude and direction of the resultant vector. Then the third side represents the magnitude and direction of the resultant vector. That is the triangle law of vector addition. So it basically explains what is on the board. That if you have two vectors representing the two sides of a triangle with the order of magnitude. Please mute yourself if you haven't muted. I beg you. It's giving me the kind of feedback here. So if you have the two sides, okay, of a triangle with the order of magnitude and direction, that is why, this is the reason why when the two vectors are not following the order, you must realign the directions. Because the two sides of the triangle, okay, must be in the order of magnitude and direction. So if one is here and the other is here, then you must realign their directions so that they follow, the directions follow a certain order. So equal vector, or using this one, equal vector. Then the two vectors A, B, this time will follow in the directional order. Then you can pick the third part The third part following the order represents the resultant vector. And that's a triangle law of vector addition. Please, is there any question? Okay. Then yesterday we looked at when two vectors are inclined to one another and the angle is acute. When the angle is acute, how do we go about that? And we saw that if you have two vectors connected in this manner, so vector 1, let me manage space. So vector A, and then another vector B. A quick revision for those of you who were watching Arsenal Real Madrid. So we have two vectors. The angle between them is theta. Theta here is acute. Theta is an acute angle. Theta is acute. Then we saw that here the magnitude and direction must also follow a certain order. It must also follow a certain order. So we must realign directions. Realign the direction so that it follows a certain order, sense of orderliness. So we equally use the equal vector approach as we use for when they are perpendicular. And then another vector here. So here we resolve the two forces into a parallelogram. We resolve it into a parallelogram of vectors. So once this is the equal component of this, same magnitude, same direction, we can also call this as B. So once this side is also equal to this, same magnitude, same direction, we can also call this as A. Having done that, you see, we have this shape known as a parallelogram. Okay. So we are resolving the vectors into parallelogram of vectors or shape. And don't forget, parallelogram is such that opposite interior angles are equal. So if this is theta, this side is also theta. Okay, this B is parallel to this B. So when two lines are parallel, they have the same slope. They have the same slope or gradient. So when we extend this line, when we extend the x-axis or the east axis, then we can say that because this side is parallel to this side, the angle between the x-axis and this must be the same. So if this is theta, this will also be theta. Okay. If this is theta, class, what will be this angle? Let me change color because I'm a color man. If this is theta, what will be this angle shaded in pink? Yes. Anybody?
So please 180 minus theta.
180
Exactly. This is 180 minus theta. Thank you. So when we realign, check the direction, then we can say that the resultant vector will be drawing a vector from the tail of A to the head of B. So this will represent the resultant vector. And it also let's call this C. Okay. Now their directions also obey the triangle law of vector addition. We have two sides of the triangle AB. Okay, in that order of magnitude and direction. And so the third side represents the resultant. So we can also say that still C, the vector C is equal to A plus B. But Imelda, are you here? Imelda?
Yes.
Yes.
I'm
This can only be used for scaled drawing. Now, because it's on scale, okay, so before we talk about the formula, we resolve this into a parallelogram. So let's also state the parallelogram law of vector addition. The parallelogram law of vector addition. Are you ready?
Yes, please.
If two vectors are represented by two adjacent sides, if two vectors are represented by two adjacent sides of a parallelogram, if two vectors are represented by two adjacent sides of a parallelogram which are directed away from their common points, which are directed away from their common points, then their sum into brackets resultant vector. Then their sum put into brackets the resultant vector. Is given by the diagonal of the parallelogram passing away through that common point. Is given by the diagonal of the parallelogram passing away through that common point. I'm repeating this. If two vectors are represented by two adjacent sides of a parallelogram which are directed away from their common points, then their sum into brackets the resultant vector. The sum refers to the resultant vector. Is given by the diagonal of the parallelogram diagonal of the parallelogram passing away through that common point. Passing away through that common point. So what
Please, you said two adjacent sides.
if two vectors are represented by two adjacent sides of a parallelogram, two adjacent sides of a parallelogram which are directed away from their common point, which are directed away from their common point, then their sum into brackets resultant vector is given by the diagonal of the parallelogram passing away through that common point. This is the parallelogram law of vector addition. So what it means is that if two vectors are represented by the adjacent sides of a parallelogram, okay, which are directed away from a common point. So we have two vectors which are the adjacent sides of a parallelogram. This side, if this is A and then this is B, A and B are the two vectors which represent the adjacent sides of a parallelogram which are directed away from their common point. This is the common point where they all act. Okay, they are directed away, meaning there's an angle between their common point, theta. Okay, then the resultant or their sum, which is the resultant, is given by the diagonal of the parallelogram. So when you resolve it, when you resolve by realigning the vectors, okay, so that if it will follow a certain order, then the diagonal from that common point, which is this, the common point is O. The diagonal from that point will represent the resultant, or yes, the common point. Frank.
So A plus B is equal to the resultant.
So by yes, I said after the resolution, this same parallelogram forces which are resolved into a parallelogram also obey the triangle law of vector addition, that C, which is the resultant, is equal to A, the vector A plus the vector B. But as I always say, you can only use this to find the resultant if you have a scaled drawing, a drawing which is drawn to scale on a graph. If it's not a scale drawing, you can't use this. You must use the formula. Frank, are you okay?
So, and the position you put the A is not adjacent to the B.
No, these are the adjacent sides of the parallelogram. Of the parallelogram. It refers to the whole parallelogram. This is one side of the parallelogram. This is another side. So A and B represent the adjacent sides of the parallelogram. That's what I mean.
Okay, sir.
Frank, your parents must pay me money for answering your questions. Okay. All right. So let's look at the formula. Yesterday, we resolved this and then saw that if you have a situation of this nature and it's not a scale drawing, then you must use a formula, which we derived and then saw that we must use cosine rule. Cosine rule. Cosine rule. We derive the cosine rule, so I'll just write it for you and then we use it today because we'll derive it in another when we consider obtuse angle. Anita, are you there? Okay, so here our resultant is C. So from the cosine rule, we saw that C squared will be equal to A squared plus B squared plus 2 times A times B times the cosine of the angle between the two vectors. This is the cosine rule. Yesterday, if you recall, we used forces. So if the sides, if B is equal to F1 and A is equal to F2, then we represented C by the resultant. So we came to the conclusion that the square of the resultant will be equal to F1 squared plus F2 squared plus 2AB. Sorry, I'm still living in AB. Plus 2 times F1 times F2 times the cosine of the angle between the two forces. Therefore, if A, B, and C, then C would be equal to the square root of A squared plus B squared plus 2 times AB times the cosine of the angle theta. If we are using forces F1 and F2, then F, please, this is a subscript representing resultant. F resultant is equal to F1 squared plus F2 squared plus 2 times F1 times F2 times the cosine of theta. This is the cosine rule. So for this, okay, later I'll explain. Hey, Kingsley, leave my board alone. Okay. Now direction. Direction yesterday in deriving the cosine rule, we created a right angle triangle and then got we created a right angle triangle and then got this part to be, this will be B sine theta. This will also be B cos theta. So assuming this is O, A, B, C, D, we saw that considering triangle, considering triangle OBC, meaning the bigger right angle triangle. If we are looking for the direction of the resultant, which is this direction, I mean, alpha is smaller than beta, theta is this whole angle between them, alpha. Because we have a right angle triangle OBC, when we take tangent of alpha, which is tangent is the ratio of the opposite side to the adjacent. So tan alpha is BC over OC. And under this context, BC is B sine theta divided by OC, which is actually OC is actually OD plus DC. Okay. OD plus DC. And OD is A. So A plus DC, which is B cos theta. So when you take this ratio and then you take the tan inverse, you can find the direction of the resultant. So tan inverse, we'll solve. And yesterday we solved question. I'll give you another question so we can use this to try again once again. So you do relax. Relax. And Frank, don't ask questions now. Okay. So the direction of the resultant is this. Now there's another way of representing the cosine rule. Theta is acute. Its corresponding obtuse angle is 180 minus theta. So theta, which is equal to acute, which is an acute angle, its corresponding obtuse angle is 180 minus theta. So this is equal to the corresponding obtuse angle. So when you take 30 degrees, its corresponding obtuse angle is 150. When you take 60, its corresponding obtuse angle is 120. When you take 70, its corresponding obtuse angle is 110. Okay. Now, whenever you draw a circle and then divide it into quadrants, there's the first quadrant from 0 to 90. And 90 to 180 is the second quadrant. 180 to 270 is the third quadrant. The fourth quadrant is 270 to 360. Within the first quadrant, which is this, when you take tan of an angle, sine of an angle, cos of an angle, they'll all be positive. So within the first quadrant, we said that all trig ratios are positive, all. Within the second quadrant, only sine is positive. Tan and cosine are negative. So only sine is positive. Within the third quadrant, only tangent is positive. It means that sine and cosine are negative within the third quadrant. So second, third, then fourth. Then within the fourth quadrant, only cosine, cos, is positive. The rest are all negative. So for easy remembrance, we draw a circle 0, 90, 180, 270 back to 360. This is A all. This is sine. This is T. This is C. So we say all silly tomcats. We are doing it in the order of first quadrant. First, second, third, and the fourth quadrant. So we are all silly tomcats. All silly tomcat. Just to help you remember, it means that other books also use cast. Cast. Cast is confusing in the sense that this one starts from the fourth quadrant. Meanwhile, you have to understand that this is the first, second, third, and fourth. But cast, because of the letter C, it starts from the fourth quadrant. Sometimes it's confusing. If you could master it, it would also help you. Class, are you there?
Yes, please.
Okay.
Yes,
So,
sir. Sir,
hello.
please, the thing you just do, the sine or tan and then the cos,
Yeah.
is it for only when theta is an acute angle?
You see, I'll answer you as we move on. It can be acute, it can be obtuse. Theta is an angle. But within what all that we are saying is that over here, don't forget, let me answer you straight away. Imelda, acute angle would only be within from 0 to 90. Because what is an acute angle? Acute angle is any angle which is greater than 0, okay, and less than 90. So acute angle will be only limited here, okay, from within the second quadrant, from 90 to 180 wouldn't be an acute angle, obtuse. Are you okay?
Yes, please.
So acute angle is limited to only the first quadrant. So within the first quadrant, when you take sine, cosine, tangent, you can try it on your calculator. Take any acute angle between 0 to 90, maybe 60. When you the sine of 60 is positive, root 3 on 2. The cos of 60 is also positive, half. The tan of 60, tan 60. I'm trying to recall. Old age is catching me. You have calculated root 3 on what?
Sir, the tan of 60 is just root 3 on 3.
Is that root 3 on?
3.
Okay.
Sir, no, it's just root 3.
So it's okay. Later on, I'll teach you a very easy way of memorizing this. Okay. So within the first quadrant, sine, tan, cos, they are all positive. When you come to the second quadrant, okay, only sine is positive. All the rest are negative. So any angle which is obtuse beyond 90, 120, if you take sine 120 is positive. Sine cos 120 is negative. Tan 120 is equally negative. And within the third quadrant, that's it. So take notes of this. Now, let's see how we can apply it. Anyway, before we continue, if you have any question on what I've taught so far, kindly ask questions. Okay, I guess there's no question. Frank, do you have anything to ask?
No, please.
Giovanni, and then Godfrey.
No, sir.
Okay. And Frank, if you ask, your parents will not pay you, so don't worry. They they've been paying already, so you can ask. Okay.
Okay, sir.
Okay, so we can also express the cosine rule using the corresponding acute angle. You see, the acute angle theta, its corresponding obtuse is 180 minus. So because cos theta must be equal to negative of cos 180 minus theta. Now, can somebody tell me why this negative, why I have this negative sign here, instead of writing cos theta is equal to cos of 180 minus theta, I have negative here. Can somebody tell me why? Giovanni.
Sir, please, because when you use cos for angles above 90 degrees, you get negative. So once you add the negative to the cos, it cancels out the negative, making it
Eva,
positive.
let's clap for Giovanni. Class, let's clap for him. A resounding round of applause. Let me hear it from your homes. Oh, you are not clapping. Oh. Giovanni, you are not even clapping for yourself. Okay, so it's based on this same reason which I just said. Because cos 180 minus theta is obtuse, which falls within the second quadrant. And I just said that within the second quadrant, only sine is positive. So once 180 minus theta is an obtuse angle, then its cosine must be negative. That's why we have it here. Are you okay?
Sir,
Hello.
is it moving clockwise or anti-clockwise?
It is anti-clockwise. First, second, third.
Yeah.
Fourth. Imelda,
Sir, so it's negative.
your parents must also pay. Come again.
Sir,
Somebody
is that why it's negative?
yes, because we are considering an obtuse angle which falls within the second quadrant, and within the second quadrant, only sine is positive. Cosine and tangents are negative. The reason why I have negative attached to the cos 180 minus theta. Okay. Now, we want to expand this. We want to expand something. 180 minus theta is compound angle. You see, theta is just a single angle. When we add or subtract another angle, we make it becomes compound. So compound angle is basically two different angles that are being added or subtracted. Now, under trigonometry, which you will do, relax. As a physics person, I'm only applying the mathematical concept, which you will do later on. If you have a compound angle, and I'm giving you illustration, cos of A plus or minus B, meaning that it can be plus or minus. Okay. The expanding of this is equal to cos of A, the cosine of one angle, times the cosine of the other angle, B. Now, if the operator is plus, so if it is cos A plus B, then the the operator be separating this will be minus. So where you have plus, it will be minus. Where you have minus, it will be plus. So let me do. Hello.
Please, why?
It's a formula. It's just a formula. Okay. It's a formula. I'll teach you. I'll give you the formula and how it is applied, so you relax for me. So if you have two compound angles added and you are expressing the cosine of it, cos A plus B is equal to cos A times cos B. The operator here is plus. The operator must be minus. Minus sine of A times the sine of B. Example. Cos 75 is equal to, I can expand cos 75 to be cos of 45 plus 30, isn't it? Class, isn't it?
Yes, please.
On your calculator, you can just punch cos 75 and get the answer. But we can also use this formula to solve it without punching calculator. So look at how. First, press on cos 75 and then give me the answer first. Yes, continue.
Sir, please, I have a question.
Ask your question.
Sir, please, how did this sine A, sine B come into the formula? Can you please go over it? Thank you.
No, you see, I'm not proving the formula. I'm giving it to you. That if you have compound angles A and B and you have determined the cosine of it, cos A plus B is equal to whatever I have written here. So continue. I'm not proving the formula. I'm giving that to you. Are you okay?
Yes, please.
So the application of the formula is what we are doing. What is cos 75, Giovanni?
Sir, please, 0.258.
Give it to me in sets.
So it will be 0.3.
No, in sets.
Root 6 minus
Root
2 over 4.
root 6 minus
Root 2 over 4. Over 4.
all over 4.
Yes.
So when you are calling, you have to call it well, else. So cos 75, let me write it here. It's equal to root 6 minus root 2 all over 4. Okay, so let's use this to confirm the same answer. So we have cos 45 plus cos 30. 45 plus 30 is equal to 75, right? So when we use the trig identity or the formula, we have cos 45 times cos 30 minus sine 45 times sine 30. Now cos 45 is root 2 on 2. Confirm it for me. True or false?
True.
Cos 30 is also root 3 on 2.
Yes.
Sine 45 is also root 2 on 2. Then sine 30 is equal to how? Confirmed.
Yes.
Let's multiply. root 2 times root 2 is equal to root 6. This divided by 4 minus numerator times numerator, we have root 2 divided by denominator 4. This is equal to a common denominator 4 and the numerator root of 6 minus root of 2 times the proof. All right. So we are using just the identity to prove our facts. Okay. Now, if you are given cos A minus B, cos A minus B, the identity or the formula is also cos of A times cos of B. The same thing, but the only thing which will change is that the operators separating the two angles are minus. It's a minus. It will change to plus here. So plus sine of A times sine of B. Example, find cos 15 degree. Gerard, let's hear from Gerard before. From Gerard. Gerard, it's a mistake. I can determine cos 15.
So it's a mistake.
It should always be a mistake, okay? I can determine cos 15 without using calculator. And this is how I can do it. 15 is equal to 45 minus 30, isn't it? So this is the same as cos of 45 minus 30. It means that my two angles, A is 45, B is 30. So I can also use this identity to find 15, cos 15. Okay. And Quentua, what is cos 15? Give me the answer. Then we use the identity to try.
Root 6 plus root 2 over 4.
So is that cos 15 is
Root
root
6.
6
plus root 2.
all on 4.
All over 4.
Okay. So I want you to use the identity to try if you get the same thing. The two angles which will subtract to give you 15, it were 45 and 30. So cos of 45 minus 30 . So this is cos 45 cos 30 plus sine 45 times sine 30. Interestingly, Giovanni.
Please, I don't get it.
Come again.
Step is the cos 15. How do you get root 6 plus root 2 over 4?
And that's what I'm saying. We have to use the identity. She pressed or inputted cos 15 on the calculator and then called the answer for me. So we are using the formula to confirm. Okay. Giovanni.
Sir.
Osafo.
Sir, the course, why didn't you make it maybe something like 10 plus 5?
Good. You see, we have standard angles. You see, whilst we do it, I'm able to tell you the value of cos 15, cos 45, cos 30, 60, 90, but we don't have that for 5 and 10. So we have, anyway, you do this in elective maths, but we physics apply it. As you grow, you will understand. We have standard angles. We don't have it for 5 and your 10, so that we use that. No. Are you okay?
Okay, sir.
So we use the standard angles to do this. And the standard angles are 30, 45, 60, 90, 0, 180. Okay. So I can tell you cos 45 without punching calculator, because there is a way to do it, which I know, which I'll teach you as we move on. So cos 45 is root 2 on 2. Cos 30 is also root 3 on 2. Plus sine 45 has the same value as cos 45. Root 2 on 2. Sine 30 is half. So Frank, is because of these standard angles, okay, the reason for which I could tell the values without punching calculator. And in doing this, we use standard angles, okay? So when you multiply, we have root 6 over 4 plus root of 2 on 4. And so this is equal to a common denominator 4 root of 6 plus root of 2. Okay. Then let me come back to my application. Giovanni, are you okay? Giovanni,
Sir,
are you okay?
sir, please, I'm confused as to how you got the root 2.
How I got what?
The root 2.
Just point the values on your calculator. Cos 45, it will pop up. Sine 45, it will pop up. So for the meantime, use your calculator. Okay, as you grow, I'll teach you.
Sir, please, why are you using cos 15?
Pardon? Pardon? It's an example. I just gave an example. Okay. The 75 and 15 were examples, just to clarify the formula which I gave you. Okay.
Okay, sir.
All right. So cos theta is equal to negative of its corresponding obtuse angle 180 minus theta. Now I can expand cos 180 minus theta using the identity I just taught you. Yasmin and Co, are you there? Daisy, I hope you are not dazing.
No, sir.
Okay. Okay, so let's use the identity to expand this. Cos 180 minus theta will be cos of 180 times cos of theta. The operator here is minus, so it will change to plus sine of 180 times sine of theta. Now cos 180 is equal to -1. Frank, standard angles. So I need not to be told, I know. Times cos theta plus sine 180 is 0. So 0 times sine theta. So -1 times cos theta is equal to negative cos theta. 0 times sine theta is 0. The whole thing is equal to negative cos theta. What it means is that when you expand cos 180 minus minus theta, it is equal to negative of cos theta. This also implies that cos theta is equal to negative of cos 180 minus theta. Please, if you have any question to ask before we continue, whilst I check on your messages. Okay. Giovanni. Giovanni, I'm listening. Oh, it's a mistake.
So, this was into bracket 180 minus.
Giovanni, come. Your line is dropping.
Sir.
I'm listening.
Sir, please. What's the cos into bracket 180 minus theta used for?
You see, okay, you understand. I get your question. You understand. Let's go back to our drawing. B and this B are parallel, and parallel vectors have the same slope. So if this is theta, this must also be theta. Okay, and so this is 180 minus theta. Now, when we went through the whole cosine rule formula, we got this. Okay, but we are also saying that cos theta is also equal to negative of cos of 180 minus theta, which is this angle. So we want to substitute this, the right hand side, in place of cos theta here in the cosine rule formula. Okay, to get another equation representing the cosine rule. That is the usefulness of cos 180 minus theta. So once we have seen that, or it's realized that cos theta is also equal to negative cos 180 minus theta, we want to substitute negative cos 180 minus theta in place of this to express the cosine rule in a different form. Class, are you with me?
Yes, sir.
So that is the essence of... I'm coming. Hello, I'm coming. Let me pick this one and get back to you, okay? Okay, so back from commercial break. So all that I'm doing is that I want to express this, the cosine rule, in a different way. Cos theta is equal to this. So in place of cos theta here, in the cosine rule formula, I can also substitute its corresponding obtuse angle. Please relax. The understanding will be clear when we start solving questions with it, okay? I know because of your level in physics or maths, that is part of the problem. So you, as we solve questions with it, it will be clearer to you. So we have c squared giving us a squared plus b squared plus 2 times a times b times the cosine of theta. Now we've managed to find that I'll identify that cos theta is also equal to negative cos of its corresponding obtuse angle, 180 minus theta. So in place of this, let's substitute whatever we had for it, making c squared to be equal to a squared plus b squared plus 2 times a times b times, now cos theta is now this, so minus cos of 180 minus theta plus, please, are you with me?
Somehow.
I'm more than Webufu. That's somehow. So now negative times positive is equal to negative minus 2ab cos of 180 minus theta. This is another form of cosine rule, but this is when you use the corresponding acute angle. Let me give you a question. Then we apply the question, okay, the concept in solving this problem. Then you understand what I'm saying very well. So two forces of magnitude so we have F1. This is 50 Newton. So the two vectors, this is 100 Newton. You see, they form the adjacent side of a parallelogram, okay, from their common point. The angle between them is, Imelda, give me an angle separating them, acute. Imelda, wada.
Sound
Angle. Giovanni.
70. Yeah, 70.
70 degree. Giovanni, I hope your hand is not up.
No, sir, please, in one of the videos you sent us, you use this same rule, the one that has the 180 minus theta, to solve for two forces acting on one body.
Yes, we'll use
find the resultant force.
We'll use the same thing. So I'll use both. So you relax. Okay. Okay. So let's realign it so that it obeys the parallelogram law. So this is also 50 because this is equal to this. This is 100. So because this is parallel to this, they must all be at the same, have the same slope. I'm not, by that line, I'm not extending the force. So we just the x-axis or east-west axis. So if this is parallel to this, then if this angle is 70, this must also be 70 degree, meaning the remaining angle is 180 minus 70, which is 110, right? Class, are you there?
Yes, please.
Then the resultant must acts along the diagonal from their common points. Now, will the direction of the resultant go up or down?
Up.
Okay,
Sir, please go up.
thank you. So F resultant. Okay. So when we resolve, you remember when we resolved it into a right angle triangle, we saw that the resultant, the square of the resultant must be equal to F1 plus F2 squared plus 2F1 F2 times cos of the angle theta. We can also get the same results when we use the corresponding obtuse angle, which in this case will be F1 squared plus F2 squared minus 2 times F1 times F2 times the cosine of the corresponding obtuse angle, which is 180 minus 70. Osafo,
Is it compulsory to use the F1 and F2?
you see, they are letter representation because they are forces. That is why I'm using F. If they are velocities and you want to use V1, V2, fine. Don't forget, I earlier also used A, B, and C. So it's a letter representation, but you must understand letters used in each situation. Are you okay?
Yes, sir.
All right. So class, I want you to use this and this. Let's see what you have as the answer for the resultant force. Start with. I've given you values of F1. This is F1. The 50 Newton force is F1. Then F2 is a 100 Newton force. So use both formulae and then tell me what you had as your resultant force. Are we through?
Yes, please.
What are your answers? Yes, Imelda, what's your answer?
Sir, I had 15,900.
Did you use both formulae?
No, sir.
No, I
the F
asked you to use both cos theta and cos 180 minus t.
okay.
Gideon,
So, this formula, I had 113.32 Newton.
for both formula.
So, please no for the first formula.
No, I asked you to use both. When you use the acute angle and the corresponding obtuse angle. So after developing the concept, we'll just solve questions which would enable it stick. So you don't worry. Okay. Just fasten your seatbelt. Let's do it together. Mary.
Sir, for the first one, I got 126.175.
Then the second one.
I got 95.28.
No, you must get the same answers.
Okay.
Look at it again.
So, please, I got the same answer for both.
Yes, you must get the same.
You must get the same.
So, please, I got 113.3.
Yeah, okay. So just if you are getting different results, just recheck, okay? Then something must have gone wrong. Valerie, Sally, and the rest of you, please let me be hearing your voices, okay? Nicole, Nana Kointua.
Sir, please, I have a question.
Okay.
Sir, won't the FR squared, won't you eventually square root it, since you're not looking for FR squared, you're looking for FR?
Nana Kointua, you know, yesterday we did this. I told you that if FR must be equal to the square root of all that. Even this morning, I reviewed it.
Okay, so I just wanted to be sure.
And that's how it must be.
Okay.
Okay, so a quick confirmation. Let's confirm. Mary, have you been able to figure it out?
Yes, sir. So I got the same answer
You
as
must.
the first.
Exactly. Imelda, Anita, Yasmin, Ida.
Sir.
What are your results? Osafo and Co. Speak. Extra.
There. So I did the first one. I had the same answer, 126.095.
Exactly.
For both of them.
So all that I'm trying to let you understand is that the cosine rule, the cosine of the angle, you can use the angles between separating the two vectors, or you can also use the corresponding acute angle. But the only difference is that if you use the angle between the forces, it must be plus. If you use the corresponding acute angle, it must be minus. So if the angle between the forces or vectors is theta, then F1 squared plus F2 squared plus 2F1 F2 cos theta. If you want to use the corresponding acute angle, which is cos of 180 minus theta, it will be FR squared being equal to F1 squared plus F2 squared minus, the plus will change to minus 2F1 F2 cos of 180 minus theta. That is all. That is all. Elitia, Nana Kumi. Okay, can you help me determine the direction of the resultant? What, the same question. Help me determine the direction of the resultant force. Direction of the resultant force. Give it a try. Whilst, for the benefit of those who perhaps will not get it, let me. So F1 is 50. So 50 squared plus 100 squared plus 2 times 50 times 100 times cos of 70 degree. Fifty squared is 2,500. This is 10,000 plus 100 times another 100 cos 70. Let me punch cos 70. Cos 70 is 0. Okay. 3, 4, 2. Yes. So when let's sum up 2500 plus this is 12,500. Then 10,000 times 0. 0.342. This is 3420. And when you sum this up,
Finally.
finally what?
So I'm having some connection problem.
Marilyn. Finally you are here.
Yes, sir.
Okay. You are welcome.
Thank you, sir.
Then the resultant is equal to the square root of 15,920. Okay. The square root of 15,920. This is 120 26 approximately. I'm just choosing to run it to the nearest whole number. In exams, you should write about 126.17. Okay. So this is it. This is the resultant. And when you use the second formula, the value must be the same. The value must be the same. What about the direction? Have you managed to, work that out? Class, direction. Or you couldn't direct it? Frank and Co, Giovanni, Gideon, what about the direction?
So please 26.50.
Okay, so with direction, I want to use the other rule. So this side, this will be 50 sine 70. Then this side, it must also obey the triangle law of vector addition. This side must also be 50 cos 70. So that if I take the tangent of the angle to the x-axis, which is this angle alpha, tan of alpha would be equal to the opposite, which is 50 times sine 70 divided by the adjacent. The adjacent will be this whole distance. Okay, so 100 plus
50
cos 70. So class, help me determine 50 sine 70. What is 50 times sine 70?
$46.9846.
Okay, so 46. All right, hold on. Points 98984. What is 100 plus 50 cos 70?
117.101.
117.101. Okay, so let's divide. 46 divided by that.
0.4012.
0.4012. Is that it? Then take the tan inverse of the decimal value. Take the tan inverse of that.
21.60.
So let's take that to be approximately 22. Okay. Approximately 22 degrees. And I'm doing this because it's an angle. Hey, Gerard. Gerard. Gerard, mute yourself.
The network.
Elikam.
Please, my network, sorry.
Okay. All right. Then There is another formula we can use for the direction. That is using the sine rule. Sine rule is a ratio of Giovanni.
Sir, please, are we saying that the direction is 22 degrees?
Yes, from X, meaning this angle, alpha. Okay, this angle is 22 degrees from the X or from the east. So when we are at the east, to get the direction of the result, we must measure an angle of 22 degrees. That's what we mean. Are you okay?
Yes, sir.
In fact, let me mute all before, because some of you are really. Frank, ask your question.
Sir, please, what if it's scale? How will you find the angle?
What if it's
The diagram is scale, yes. It's on a graph.
Oh, you measure with a protractor. As for that, it's not even difficult. Okay. Asafo.
Sir, the direction, is it going, which direction is it going to? Is it the north or the south or the east or the west?
No, you see, this one, the line, the 100 Newton force F2 lies on the x-axis or along the east axis. So it means that this angle of 22 degrees is from the east or from the x-axis. So when you measure 22 degrees from the east or x-axis in an anti-clockwise direction, because the resultant is up. Asafo, are you okay?
Yes, sir.
All right. Then the cosine rule, the sine rule, which is another method of measuring the angle, is a ratio of the angle to the opposite side. Okay, so when I take sine of the angle in question, which is alpha, divided by which vector is opposite to this angle? Which vector or force is opposite to this angle alpha? Looking at the diagram. Hello, anybody? Look at this angle and then the vector which is directly opposite to the angle. Imelda and Co, Anita, Monkasa. Which vector or force is opposite to this angle?
Sir, please, is it the 15 Newton?
It's 50. This is the angle in question, and the side which is opposite to it is this. Frank.
So it's opposite if they meet at one point, or
Oh, your house is opposite to somebody's house. Meaning, if your house is here, okay, the direct house which rightly faces your house, okay, in the opposing direction is the opposite. So this is the angle alpha. Let me clear this bigger. This is the angle alpha. The vector which is opposite to this angle is this one. Don't forget, I brought this for the sake of the using Pythagoras theorem. So originally, this is not here. You understand this into this as we move on. But originally, this is what we have. And so if once there's the angle, the side which is opposite to the angle is this side, the 50 Newton. Okay. So sine of the angle divided by the magnitude of the side equal to the sine of the other interior angle. The other interior angle is this. this is 180 minus 70, which is 110, 110, divided by, what is the vector opposite to this? Class, what's the vector opposite to this sine of the angle? Or this angle? Pardon?
50.
I need to speak up.
I said 50.
Look at this angle and the side of the triangle which is opposite to it. That's the resultant force.
Yes, 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 yes.
Yes, F resultant must be equal to the sine of the other remaining angle. They are all equal. Okay, so if this is 130, okay, we don't know this. So alpha, let's assume this is also beta. Then this is also equal to sine of the other remaining angle in the triangle, beta, divided by, what is the side opposite to it? What is the side opposite to that angle? Class, what's the force opposite to this?
F2.
F2, which is 100. So, you see, you determine alpha by equating it to other two known quantities. Okay, meaning sine this over 50, sine this over this, they are all equal. So you can equate any two depending on the available information. So sine of alpha, which we are looking for, divided by its opposite vector, which is 50, is equal to, we can equate it to sine of 110, 110, divided by, we found the resultant, 126. Okay, we can't equate it to this because here, when we do so, we don't know the angle yet. So we don't know the angle yet, so we can't equate to this. If we know beta, we can equally do so. So sine alpha therefore becomes 50 times sine 110 divided by 126. Class, calculate that for me quickly. Our time, we have just 5 minutes to close, so let's be snappy with that. So sine alpha is equal to multiply, find out what sine 110 is, and then multiply that by 50.
46.984.
Is it the numerator?
Yes, sir.
46.984 divided by 126.
0.372.
0.372. 0.373.
Okay, then find the sine inverse. Alpha is equal to the sine inverse of 0.373.
$21.900.
Approximately 22, as we earlier had, isn't it?
Yes, sir.
This is where we draw the curtains on our meeting today. If you have any question, ask. Before I draw the curtains, because my curtains are dirty. I need to quickly wash the curtains. Frank, any question? Hey, Frank, in fact, your parents will pay. Okay, go ahead.
I don't understand how it became sine inverse. Like,
No,
or
when you are looking for an angle, you need to take the sine inverse of the decimal value. Okay, we have, it's unfortunate, my space, we have sine of alpha giving us 0.373. Okay, so we are ahead, Frank.
Why is it sine of alpha?
Oh, we are using the sine rule. Sine rule, sine of alpha divided by the opposite vector, which was 50, equal to the sine of the other known interior angle. So this is a different formula we are using, the sine rule, divided by the ratio of the resultant. And because we had determined the resultant, okay, our resultant force was 126. So this is the sine rule. I'll elaborate, okay, more on the concept next Tuesday. So you don't worry. Okay. Another method of finding the direction of the resultant using the sine rule. So I'll throw more light on that. So our angle, which is unknown, is alpha. So when you make sine alpha the subject, it means you must eliminate this denominator 50 times 50. So this 50 cancels out. And we have sine alpha giving us this. And this is a known value, point sine 110. Sine 110 is equal to 0.93969 times 50 divided by 126. Okay. Frank, are you okay?
Yes, sir.
So it's just a new formula we are using. So the numerator is giving us 46.984 divided by 126. So if you divide this by 126, you have 0.3728 or 29. Then to find the angle, you just take sine inverse. On your calculator, you press on shift sine and then you input your decimal values. So shift sine of 0.3729. And we have 21.89, which is approximately 22 degrees. So it goes to confirm the same approach or method we used to find the direction earlier, which we use tan, Pythagoras theorem. So the value is the same so long as you are doing the right thing. Okay. So I'll talk more on the sine rule, next week during our meetings. But I will send you an example to try your hands on. Okay. So enjoy your Easter break. Take care because I need each one of you to be fit and kicking next week. So please take very good care of yourselves for me. Okay, do not throw away your books. Revise because physics, is not an something to easy walk over. You need to understand the concepts and then practice. So please be reviewing. I'll send you assignment as usual. May the good Lord be with you. Take care of yourselves, and then we shall continue our wonderful meeting next week. Bye-bye.
Bye bye.
You've actually taken all the energy out of me.